Back for part two. Here we're asked to sketch a function of a graph that is differentiable. What does that mean? Well, remember, it means there's no discontinuities, no strange things like cusps or vertical tangents or anything like that. So it has to satisfy the following conditions. So the conditions are f prime at x is greater than 0 when x is less than 0, and f prime at x is less than 0 when x is greater than 0, and f at 0 is 4. So a lot of stuff going on there. What do we do? Well, let's draw a chart and start sort of filling in our, what's going on. First thing that jumps out at me is that f at 0 is 4. All right. Okay. So f at 0 is 4. And then it also serves as a cutoff point for the derivative. So the derivative is greater than 0 when x is less than 0. So over here, f at x is greater than 0. So it means the function is increasing to there. The function is increasing to get to 0. So it could be something like this, right? And there's lots of things that could go like that if you want. Anything where f at x is positive, it's increasing to get to 4, and it's decreasing otherwise. F prime at x is less than 0 here. So it could look like on this side, it could be a parabola, or it could be something like this, right? As long as it's going down for all x greater than 0. Notice that I could have started this problem with a sign chart if I wanted to, where I'm thinking about f prime at x, and I know at 0 we don't know what's going on, but I can see it's positive on this side, which means increasing, 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 and negative on this side, probably 0 there, and indeed in my graph it is. Dandy. What about B? Another one. F prime at x is greater than 0 when x is less than -1, and when blah 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 blah. Big, long, lots of stuff going on. Well, let's get the sketch going. I'm actually going to start with the sign chart, just like I said before, because I think that's going to be easier in this case. So I have f prime at x. So f prime at x is greater than 0 when x is less than -1. So here's -1. And over here, f at x is greater than 0. So that means it's increasing in this section, right? That's what that means. And when x is greater than 2. So if I go over here to 2, from there over, increasing, 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 increasing. And f prime at x is less than 0 in between. So between -1 and 2, it's negative. That the derivative is negative. So what's going on at -1 and x equals 2? Probably a min or a max. And notice I kind of know what's going on because this is increasing, 0, decreasing, decreasing, 0, increasing. There's going to be a max at x equals 1 and a min at x equals 2. So as long as I have this other thing that's true, I can make this happen. I don't know how far up or down it goes, but I know it's going to go through this point at x equals 0. It's going to be decreasing through there, right? Because its first derivative is negative, and then a 0 there, increasing, increasing, 0, negative, negative, or decreasing, decreasing, until it gets to 2, decreasing, decreasing, till it gets to 2, then increasing, increasing, increasing after. Nice. Notice, do we know what's going on with f at x? Well, we could, but we had a lot of different choices here. This could have had an asymptote, right? We don't know about that. We sort of made up the details about f at x, but f prime at x, we're pretty sure that this is it because we were given that question. Example 3. Oops. Example 3. The graph represents the derivative function of a function. So this is the derivative. And it says determine the intervals where f at x is increasing. All right, well, I am going to place everything on a sign chart first. These sign charts are so important. What color? We'll use red. Why not? So f prime at x is 0 at 1. It's 0 at 1. On this side, it's negative, right? And on this side, it's positive. So that means the function was decreasing, 0 increasing. So what does this mean here? It means there's a minimum, right? So when we get later, we're going to have to make a rough sketch that we're going to use this chart. But now I'm just going to fill in the details. The intervals where f at x is increasing. Well, it's increasing where the first derivative is positive, in here. I'm going to do set notation on one and interval notation on the other. Greater than 1. We don't include the spot where the derivative is equal to 0 because it's not increasing at the maximum, or minimum rather. Decreasing on from there over is negative infinity to 1. The x coordinates of all local extrema. Local extrema. Local extrema. What does that mean? This is mins and maxes, right? Well, just there. X equals 1. And we know it's a minimum. Okay? Dandy. What's next? Oh, if f at 0 is 3, make a rough sketch of the graph of f at x. There'll be some details that we don't know, but let's give it a go. Let's get a little more room here. Oh, we got enough room. So what do I got? F at 0 is 3. Say there. We know it's decreasing through there until we get to x equals 1. So f at 0 is 3, and it decreases until we get to x equals 1. We don't know if it goes below the x-axis or not. We got no idea otherwise. But we know that that's a minimum, right? The minimum occurs there, and then it starts increasing after that. Maybe something like this, right? Maybe something like that. That's it. Let's try the... Is this the last example? I think this is the last. This is where the good stuff happens, by the way. Determine algebraically where each function is increasing, where it is decreasing. All this graph stuff was to set up this, by the way. So this function is, remember, f at x is increasing when the first derivative is positive, and decreasing when the first derivative is negative. And so, of course, now it feels like we're going to get a chance to take a derivative. It's been a little while. Let's take a derivative. So this one is a mess. What is it? It's a product rule and a chain rule together. But be patient with your rules. You should be able to remember them. Take the derivative of the first thing. The overall, I see it as a product rule, right? We've got square times cloud, but inside the square, it's a chain rule. So when I take the derivative of square, it's 3. The derivative of the mother function is 3 bracket 2, but then I got to take the derivative of the inside thing. And then write down the cloud. Write down the cloud. Right, there's this square, write down the cloud, plus, write down the square, derivative of the cloud, and the cloud is another chain rule. 2 comes down out front. Derivative of the inside thing is 2x. And there's the part that I took the derivative of. That's the derivative of the cloud there. And I've got to think about, when is this thing positive? Well, it's positive or negative depending on the sign of this thing. Well, I need to compare it to zero, right? So I need to set this thing equal to zero so I can figure out the mins and maxes. So I am going to factor this. Right? I got some like terms here. This was supposed to be a 3. Did you notice that mistake? Thanks for correcting me. But I'm going to factor. There's 2 copies there. Do I got a 2 I can take out? I got a 2 that I can take out. I'm going to write that in front. I got 2 copies of this bracket there and 1 copy there, so I'm going to take out 1 copy of that. And then what's left over? After I take out all these common factors, I got a 3 left over there. That 2 was gone. 1 copy of this. And over here I had 1 copy of this left over. That 2 was gone. Factored out. This was factored out, and then a 2x. That was just a thought there. Okay, and then now I'm going to tidy this thing in the brackets up. 3x squared plus 9 plus 4x squared plus 6x. And there's the first derivative. Collect some like terms. Got 7x squared plus 6x plus 9. And now I'm going to set this thing equal to 0 and set up a sign chart. So this thing is f prime at x equals 0 when, well, we've got that bracket could be 0, right? We've got 3 goes over and then divide by 2, negative 1.5. When is this 0? Put the 3 on the other side. Square root never works, no solutions. When is that thing equal to 0? I could try and factor it, but I don't think it factors. The 2 F words of grade 10 math, factor formula, I don't think it factors, so we try the formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And if you're using your quad solver, yeah, you can use your quad solver, but what happens here is this is negative. The discriminant is negative, no solutions. So there's only one spot where the first derivative is 0. So let's put it on a sign chart. All that mess and there's only one solution. Wow. Okay, and remember, this isn't the original function. This is f prime at x, and so the magic spot is negative 3/2. That's where the derivative is 0. And then what happens? Well, let's do a test point, right? Do a test point over here. Say x is minus 2, something like that. When x is minus 2, then notice, what do I have here? I have a test point, but I've got 2 times, and this is just some rough work, but when this is minus 2, notice this is going to be a positive number. This 2 times negative 2 plus 3 squared is positive. This is going to be positive, right? Because this is negative 2 squared plus 3. That's some positive number. I just have to find out whether this is positive or not. And then I put that in there, and I end up getting, and bing, 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 on your calculator, it ends up being positive. And if you don't believe me, you can try that on your own. And remember, that test point sort of represents all of the points around it. Remember, it's going to be equal where we got it equal to 0, but then the other points are going to match the test point. All right, well, what about on the right-hand side? On the right-hand side, another test point might be x equals 0 is my favorite. I put in 0, and I'm going to get a positive times a positive times a positive times a positive. Positive, 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 positive. Okay, it's positive in there too. So what happens? That means it's increasing on negative infinity to negative 3 halves, and also after that. So that's a strange function, very strange function. I'm going to pause and get Desmos going just to have a look at this bad boy, but certainly we probably could use our advanced functions techniques on this to think of a sketch. We can see it's going to be the f at x is going to be 0 at negative uh, 1.5, and it's a slide, right? It's a slide. This contributes no more zeros. It's degree 5, which starts low and ends high, right? Starts low, ends high, and a slide there. And, I don't know, we might wobble in between there, and who knows what this is, but I could put in x equals 0 and get a value there. It looks like 3 to the exponent 5, that's 243 right there. And there's our advanced functions formula. And notice it's increasing on all values except for where it slides through at x equals negative 3 halves. And we just proved that using our, um, our first derivative. All right, I'm going to pause there, and we'll come back for video 3 and the last example of the day.